In physics, whenever we describe the motion of an object, we usually describe the motion of the object using velocity and speed. What exactly is speed? Well, speed is simply a numerical value, a magnitude, that tells us how far an object has traveled over some given amount of time. And normally in physics, we use average speed. So average speed is given by this formula: the total distance traveled divided by the total time elapsed. So let's do a quick calculation. Let's suppose we get into a car and we move along the x-axis from some point 0 to 200 kilometers along the x-axis in the positive direction. And then we turn around and we move backward to our initial point. So what is our total distance? Well, the total distance is 200 kilometers plus 200 kilometers backward. So 400 kilometers is our total distance. Now, let's make the assumption that it took us 4 hours for the entire trip. So, the average speed, or the speed on average of our car, was 400 kilometers divided by 4 hours, 100 kilometers per hour. So that means every hour the car traveled 100 kilometers. Now, what exactly is velocity and what is its relationship to speed? Well, in everyday language, we normally use speed and velocity interchangeably, but in physics, there is a clear distinction. Velocity tells us not only the speed or numerical value that tells us how far an object moves in some given time interval, but it also tells us our direction. So velocity has magnitude as well as direction, but speed only has the magnitude. Now, in the same way that we talk about average speed, we can also talk about average velocity. So average velocity is given by lowercase v with the bar on top. V stands for velocity, the bar stands for average. So average velocity is equal to, our formula is displacement divided by time elapsed. Notice, it's no longer our distance, but it's our displacement, which is different than distance. Displacement also has direction, and in fact, the direction of our displacement and velocity are exactly the same. So, another way to represent our average velocity is simply by changing our x along the x-axis over change in our time. So, change in displacement and our time elapsed. So let's look at the following two examples. Let's go back to this example. Let's do a quick calculation and see what the average velocity of our car was. We know the average speed was 100 kilometers per hour. What about its average velocity? Well, if the car begins at some point 0, travels 200 kilometers this way, 200 back to the same exact point, so it ends up at the same point, what was our car's displacement? Well, it was 0. That means x final, which is 0, minus x initial, still 0. So the top, the numerator, is 0 divided by 4 hours, so our average velocity was 0, even though our average speed was 100 kilometers per hour. So that's where our distinction lies. So let's look at example 1. During a 10-second time interval, a sprinter's position changes from x initial 100 meters to x final 45 meters. Find the runner's average velocity. So our runner begins at some point, let's say our x-axis 100 meters, so our x initial, our x final is 45 meters along the x-axis, and the total time it took us, the change in t, is 10 seconds. So we use this formula, specifically we use this guy here, so change in x over change in t. 45 is our final position minus our initial position, 100 divided by 10 seconds. So we get negative 55 meters divided by 10 seconds. So negative 5.5 meters was our average velocity. In other words, our displacement was this, our time was this, and we get our average velocity, negative 5.5 meters per second. So notice the negative represents our direction. In other words, negative tells us that we moved in the negative towards the left along the x-axis. If this was positive, if we went from 45 to 100, that positive would tell us that we moved this way towards the right along our x-axis. Now, let's look at example 2. How far can a person travel on a 4-hour bike ride with an average velocity of 20 kilometers an hour? So, let's once again make the assumption we're moving along a straight path along the x-axis. So we begin at some point here and end at some point here, and our change in x, our displacement, is given by change in x here. Now, this is our formula. So we are given our change in v, or we are given our average velocity. We are also given our time interval, 4 hours. That means we plug the 20 kilometers in for the v, and we plug the 4 hours for the change in t. And we get 20 equals change in x divided by 4. So we bring the 4 over, we multiply both sides by 4, and we get our change in x, or displacement, how far our bike, the person on the bike, traveled, was 80 kilometers. Notice, since we are using hours, since we have 4 hours and we're given the velocity, average velocity in 20 kilometers per hour, we don't need to convert anything. The hours simply cancel and we get 80 kilometers for the distance our bike traveled.